Right. Assalamualaikum, selamat pagi. Okay, Assalamualaikum, selamat pagi.
Salam Zah.
Salam sir.
Okay, kita
Salam sir.
topik
Salam sir.
ini.
Salam
Alright,
dia.
this will be our topic for today. We are going to talk about two things. The first one is law of motion, and the second one is about summation of force. Ada dua benda. Kalau habis kita ambil hari ni, kalau tak kita akan sambung pada waktu tutorial. Okay, when we talk about law in motion, okay, we can define law as principle or regulation. In other words, kita boleh cakap law of motion ni is the principle or regulation or rules that being followed by motion, by pergerakan. Contoh kan, kalau kata pergerakan kita tu pergerakan seperti apa cakap okay, if let's say we talk about this pen, okay, if this pen does not obey the law of motion, kalau kita lepaskan dia tak jatuh ke bawah. Instead dia akan duduk dekat tempat tu je. Ataupun kalau kita lepaskan dia, dia terbang. Fly away like a bird. Tu maksud law of motion. Meaning that whatever happen in this universe, especially motion, it follow a certain set of rules. And that rules being defined by Isaac Newton. So kita ada 3 law of motion. Okay, tu law tu kita kena faham law. Apa benda law? Contoh macam law ialah lampu hijau jalan, so everybody follow except one or two. Tapi motion tak adalah semua benda follow lah. Kalau kata ada except ni, means macam kita lampu hijau kita berhenti, lampu merah kita jalan, tu melanggar law. But in motion there are nothing that disobey the law. Everything is obeying the same law. Okay, itu law. Okay, ataupun rules. In law of motion, okay, so law kita dah ada rules. Motion, in a simple word, is movement. Motion is movement. Okay, ni dia punya definition yang lebih power lah. Action or process of moving, changing of place. Saya ambil satu je, movement. Means law of motion is the rules that we follow by movement. Okay, movement apa? Any movement. It follow the same law. Okay, so there are 3 law of motion. The first one, ini asyik terbalik, kita sambung kan. Okay, the first one is known as law of inertia. Second one, law of action, acceleration, and the third one is law of reaction. And these 3 law interrelated with one another. It always start with the first one. Okay, right. Jadi law of motion yang pertama. Before we go here, I need you to have an understanding about movement. Saya pernah tak tunjuk pada kamu Cartesian coordinate? Ni benda ni. Pernah tak? X, Y. Okay Jadi X, saya nak kamu faham benda ni. X maksudnya horizontal motion regardless of direction. Y means vertical motion regardless of direction. And we have another direction of motion. Dia macam ni. Kita panggil dia Z ataupun torque. Means an object can move forward, that is X, can move upwards, that is Y, and at the same time it can rotate. Itu pergerakan yang boleh ada pada sesuatu objek. And that pergerakan yang ketiga ni, this is known as Z ataupun torque. Jadi in describing motion, we can describe motion as this one. If the object move forward, we name it as, okay, they are force horizontal. Force horizontal dia ada value. Saya letak X ni means we don't know the value lah. Kalau objek tu bergerak ke atas, meaning that force vertical dia ada value. And if the object rotate at an axis, means that torque dia ada value. Tu kena faham Ni maksud dia value. We don't know the value. Ni FZ pula. F vertical. Okay, FH ni F horizontal ni. FV F vertical. Torque is the rotation ataupun Z. Okay, so if an object, okay, tak ada pergerakan ke depan, there is no motion forward, we call it as FH equals to 0. Maksudnya objek ni tak bergerak ke depan ke belakang. If the object does not move upwards or downwards, we call it as FV equals to 0. Maksudnya it does not move up, it does not move down. And if torque equals to 0, meaning that the object does not rotate. Ini when the object move. Ini when the object does not move at all. So the differences between 0 and x is only 1. That difference is whether there are presence of acceleration. If there are presence of acceleration, okay, velocity daripada kosong boleh jadi x. Kalau ada case deceleration, velocity daripada x boleh jadi kosong. Meaning it can change, and this change occurs due to acceleration. Jadi kondisi biomekanik, kondisi mechanic of motion ada dua je, whether there are no change or there are change. If there are changes, means there are movement and it caused by acceleration. Okay, faham dua kondisi tu dulu, kondisi static, kondisi dynamic. Okay, and then if an object, okay, let's say dia daripada kosong, okay, katalah V equals to kosong, ni kita recap balik, it goes V equals to 2, meaning there are acceleration here, and from 2, it remain 2, meaning there are no acceleration here because the velocity does not change from B to C. From A to B, ada change. Katalah daripada 2 ni, kat D pula, it become 4, meaning there are acceleration. So when this happen, there are no acceleration, this is also known as static condition. Yang ada acceleration ni, we name it as dynamic condition. Ni benda kita belajar mula dulu, the first class. Okay, so when the condition is static, it is also known as in a state of equilibrium. And this can be further divided into two: static equilibrium and dynamic equilibrium. This is an example of dynamic equilibrium because the object move, but it move at a constant velocity, means that there are no acceleration in between. That is dynamic equilibrium. If the object does not move, this is what known as static equilibrium. So what is the similarities? These two things have one similarities. At any given point, whether dynamic equilibrium or static equilibrium, FH equals to 0, FV equals to 0, Z or T also equals to 0. So there are no changes towards the system. Katalah tiba-tiba FH ni ada value plus 1, meaning objek akan bergerak ke hadapan lebih laju. If the value FV plus 1, meaning the object is going to accelerate upward. So you are going to get motion macam ni. Dia bergerak point, dia naik ke atas, so dia melompat. This is caused by FV. This is caused by FH. Even suddenly macam ni, dia pergi sini. Change of direction. So we have a certain degree. This is caused by Z ataupun T. So in equilibrium state, these three things absence. Okay, whether it is static ataupun dynamic. Tu faham yang tu dulu. Okay, when you get that, and then only we can describe the first Newton law of motion. Okay, so the first Newton law of motion said that, this is the keywords, a body or an object will remain state of rest. 1, meaning there are no velocity and there won't be any velocity. Or 2, will remain movement with constant velocity. Meaning if it moves at one velocity value, it will remain at the same velocity value. Okay, ni keywords dia. If the object does not move, it won't move. If the object moving, it will keep on moving at the same velocity unless there are external force. Maksudnya kalau kita letak satu bola, bola tu tak bergulik, dia takkan bergulik except you kick the ball. If you kick the ball, means you give external force to the ball and it goes. Okay, daripada kosong kepada sesuatu kelajuan means there are acceleration. When there are acceleration, it is not in a state of equilibrium. So Newton's first law talks about equilibrium. A body will remain equal unless we put a force on it. Tu maksud dia. A body will maintain its state of equilibrium, both static and dynamic, unless we put an external force towards the system. When we put external force to the system, there is acceleration. When that happens, there are no equilibrium because acceleration disrupt equilibrium. Ni adalah Newton law yang pertama. Okay, it talks about equilibrium. An object won't move. An object will move at a constant speed unless we put force. Ni maksud dia lah. Motionless object will remain motionless unless there is a net force. Okay, net force macam mana? Ni lah net force dia. We give it either one of this one atau kita bagi tiga-tiga sekali. It cause change to the system. So if the net force, okay, net force is FH plus FV plus Z equals to net force. If there are no net force or Fn equals to 0, means that the object is in equilibrium state. The object will not move. The object will move at a constant speed and it won't change. Itu adalah maksud first law. Okay, so everybody will remain at rest or moving with a constant velocity in a straight line unless ada external force. To change the velocity of body, force must be applied. Okay, so kawan dia, after we have discussed the first law, kawan dia is the second law. Ni contoh. Okay, contoh lah dia bagi, if we neglect friction. In our world, we cannot neglect friction, but in analysis, we are going to neglect friction. Kalau kita neglect friction, orang ni dia dah bergerak, katalah pada 10 meter sesaat, and nobody slow it down, nobody push him, he will remain gliding at 10 meter per second sampai kiamat. Itu maksud dia. Okay, itu maksud dia. Boleh faham sampai situ? Senyap. Hello.
Faham, sir, faham.
Okay.
Faham, sir.
Itu Newton first law. Okay, kawan dia, kita cerita Newton first law, dia mesti ada kawan. Okay, ni contoh. Kalau kita tak kayuh, if you don't pedal, the bike won't go. Simply because they are weak. So macam mana kita nak bagi dia bergerak? We need to pedal. We need to pedal hard. When you pedal means you put force lah, and then change happen. Itu cerita Newton law yang pertama. Change occurs based on amount of force. If there are no force, system will remain equilibrium. That is Newton law of inertia. So the partner for that Newton law of inertia is the second law, law of acceleration. Here we talks about force. Okay, kita kembali kepada contengan. Tadi we have an object with net force equals to 0. This object does not move. Now we introduce force. Ini Newton's second law, which will make this object move, or which will give this object an acceleration value. Acceleration value change the nature of the object, means from unmovable towards movable. Okay, now what we need to have is the properties of the motion. Okay, so Newton's second law express interrelationship between force, mass is the object, and then acceleration, the change of velocity, ataupun we call it as the change. Acceleration in mechanics cause changes. Okay, it cause change of a lot of things. It cause change of velocity, it cause change of shape, acceleration. Okay, so kita akan tengok kaitan tiga bonda ni. Alright, this is the keywords. When you apply force to an object, okay, applied force to an object, it will cause acceleration towards the object. Okay, the keywords, that is the first keyword. Second is the shape of the acceleration, bentuk dia. Okay, bentuk dia kita tengok kat sini. This acceleration, the criteria of this acceleration, first one, magnitude proportional to the force. Okay, meaning if katalah, okay, kita assume if 1 Newton of force give 1 meter per second of acceleration, 1 Newton force bagi 1 meter per second. Meaning for the first statement is, if you give 10 Newton, you are going to get 10 meter per second. Magnitude of the acceleration is proportional to the magnitude of the force. So if you give more force, you are going to get more acceleration. That is the first one. Okay. Itu adalah yang pertama. Magnitude proportional to the force. Berkadaran dengan force yang diberi. And then, number 2, direction of the force. If the force is like this, okay, from left to right, your object will always move at the same direction of the force. Dia bukan macam ni. Kita bagi force, bola bergerak macam ni. Zas. Ni dia punya movement. Bukan. Ataupun this is the ball, we give force, okay, nak buat sepak serong kan, bola tak pergi serong bawah, dia pergi belakang. Zas. Bukan macam ni. Or even better, this is a ball, you kick the ball goes that way. It is not like this. It will always follow the line of force. So, kalau force tu macam ni, it goes that way. If the force being introduced like this, the ball will go that way. If the ball being introduced with a force diagonal, the ball will move diagonally. That is the meaning of the second one. In the direction of the force. So if we give a force to something, the object will move following the direction of the force you've been given. Tolak kereta kan, kereta rosak, tolak. Tolak ke depan, tiba-tiba kereta bergerak ke tepi. Dia pusing steering lah, but still ke depan. Still ke depan, dia tak ada kita tolak kan. Kita lagi kuat kita tolak, lagi kuat kita tu reverse ke belakang. Tak ada. That is totally wrong. Because this is the law. Okay, they follow in the direction of the force. And then the third one is inversely proportional to the body mass. Okay, meaning of the third one is this. If we have an object, we push the object, you are going to notice that there will be some resistance. And this resistance is based on that object weight. Okay, katalah barang ni 10 kg. So, times with 10 kgms, which is the amount of gravity. So, we have 100 Newton in term of weight. Jadi kita pun tolaklah force, objek tak bergerak, because of the third properties, inversely proportional to the body mass. When we put force, there are going to be another force acted in a different direction. And this force is known as friction. Okay, cause of friction, weight. Ni yang ketiga. Jadi maksudnya, tak adalah kita kata, you put force, object fly selaju-laju mungkin. No. It won't go that way. Macam cerita apa kan? Tolak sikit, sentuh, zaz, barang tu pergi. Go along the way. Tak ada. It won't go there. Meaning, the movement is going to be proportionate. Proportionate kepada apa? Magnitude of the force. Number 2. Inversely proportional to the mass of the object. Okay, maksudnya, kalau kata barang ni 100 Newton, how much force do you need in order to make it move? The object is 100 Newton. In other words, you have friction in a value of 100 Newton. So how much force do you need in order to make this object move that way? How much F? Berapa? Ni tak payah kira boh. Tengok nombor tu dah tahu. Berapa banyak force yang diperlukan? Berapa?
100 juga se.
Mana boleh? Kalau kita bagi
10.
100. Okay.
Tak faham masa.
Ha.
Point ni tak faham.
Kalau kita bagi dia 100, kita tengok. In order to make it move, dia mesti ada summation of force. Okay. So, force yang bergerak ke kanan 100. Force yang bergerak ke kiri ialah negatif 100. Berapa value dia sekarang? 100 tambah negatif 100. Maksudnya 100 tolak 100. Sama dengan?
Sifar.
Dia boleh bergerak. Dia takkan boleh bergerak. Apa kata
Tak boleh.
we increase the force to 1. Sekarang berapa jawapan dia?
1.
1. Okay, apa maksud positive 1 ni? Meaning that it will move to the right hand side at 1 Newton. Dia bergeraklah ke kanan. Itu maksud dia. So, meaning of the third one, for the third point here, whenever we try to make an object move, although we give amount of force, there will always force that resists. Okay, so to make this object move, you need to give force above the threshold of the friction. Kalau kata objek ni friction dia 20 Newton. To make this object move, you need to have force at least more than 20 Newton. Oh, dia boleh bergerak. So kalau kamu letak 20, force dia, okay, bila kita kira total amount of force yang ada, it will be force total 20 plus, tengok berapa yang balik, tolak 20. Objek tak bergerak. Okay. Ataupun macam ni, let's say kita ada satu objek. Okay, this object is 60 Newton in term of weight. Okay, weight dia 60 Newton. If we give force of 93 Newton to the object, my question will be two. Number one, how fast? Number two, which direction? So if the case is something like this, we need to know the total force work upon the system. Okay, jadi kita ada box 60. So meaning that there are 60 Newton of force here. So in order to move this box, you need to actually pull more than 60. Baru kotak ni bergerak. Kalau kata kamu push like this, it will go there. If you push downwards, it will go there. If you push to this side, it will follow. If the force given is more than 60. So now we have force given 93, weight of the object 60. So kita kena kira total force dia. Okay, so force total for this object equals to F. Okay, F being given plus weight. Okay, so weight bergerak dekat arah mana? It depends on the force. If the force move like this, means the force is positive. So automatically weight will move in vice direction. So weight akan jadi negative. Kalau kata force bergerak macam ni, so force negative, automatically weight dia positive. Dia macam tu ya. Okay, so total force sama dengan berapa kita ada? 93 plus weight 60. So you have here apa ni? 33 Newton. Positif. Positif tak ada tulis. So soalan yang pertama, how fast? The velocity is based on 33 Newton. Which direction? To the right. Ataupun in the same direction as the force. Itu maksud dia. That is how we compute the amount of force needed. Okay, ataupun the threshold. Kita kena tengok. Okay, kadang-kadang dia tak sebut pun force friction, tak ada. Dia sebut weight. So orang faham weight bergerak macam ni. Yes, it's true. But when we push things from an angle, from a direction, the weight is going to counter the force, and that is ni, inversely proportional to the body mass. Kalau kita tolak ke atas, weight tu ke bawah. Kalau kita tolak ke bawah, weight tu ke atas. Contoh macam kita letak bola kan, bola atas air, kita nak tolak dia ke dalam. You're going to feel that the ball is push you upwards. Tu kerana pressure dia lah. So pressure is another form of mass. Is another form of force. Itu maksud dia. Okay, what is the second law? So the force being applied will cause the object to move, will cause acceleration, and that acceleration is proportional to the amount of force in the direction of the force and inversely proportional to the body mass of the object. That is second law. Okay, itu law kedua. Kayuh laju, basikal pergi laju. Kayuh perlahan, basikal pergi perlahan. But if you letak kaki atas pedal, just put a bit of force, you're going to notice that the bike does not move. It is because you are still not, you are still not going over the threshold of the friction. Maksudnya force daripada kita nak pergi depan tadi, kita nak pergi depan guna 10 Newton. Basikal ni ada 10 Newton ke belakang, so tak bergerak. Okay, kadang-kadang bila kita pijak pedal kan, it does not move. We need to push it a bit, go beyond the threshold, and then only the bike is going to move because of Newton's second law. The third point, inversely proportional to the mass. Okay, and the third law, ini yang paling simple and most of the time I'm going to say something like this. Third law is what you give, you get back. What you give, you get back. Okay, for every action, there is an equal and opposite reaction. Example. Katalah kita ada seorang mamat. Mamat ni gembira. Okay, mamat ni gembira. So what happened is, this mamat jump. Okay, jump. During the jumping process, when the mamat reach the floor, it give the floor 300 Newton of force. Dia rasa macam tu, aku bagi force yang paling banyak aku boleh bagi, so that I want to jump higher. And he jump. So my question, if this mamat inflict 300 Newton of force to the floor, how much force being returned back to this mamat? Okay, mamat ni bagi 300 Newton ke bawah, means dia bagi negatif. So, how much Newton being returned by the floor to the mamat? Based on Newton's third law, berapa banyak? Ni pun tak kira.
300.
300 lah. But, it is not negative, it will be positive. Kita nak cakap, nak tengok macam mana, we can see the mamat lompat tinggi. So, if the mamat, the same mamat, give only 10 Newton. Lantai. Ini je lah jarak dia. So 10 Newton being given, 10 Newton being received. 300 Newton being given, apa jarak berbeza. 300 Newton being received. Okay. Cuba tepuk meja tu kuat-kuat. Cuba tepuk tangan kiri, tepuk meja tu kuat-kuat macam nak roboh. Tangan kanan, tepuk slow. Tangan kiri kelepam. Soalan simple je. Kenapa tangan kanan tak sakit? Kenapa tangan kiri sakit? Kenapa tangan kiri sakit? This is the reason. Why your left hand now feel pain? Kenapa? Buat lu saya tak dengar bunyi kelepap. Tipu cheating Cepat. Tak dengar bunyi. Cepat. Tak dengar. Dah try belum? Senyap.
Kena buat rasa.
Kena lah. Oh, tahu. Kata applied biomechanics. Okey, tepuk meja sakit, tepuk pipi. Tak ada pun. But you get the idea, okay? You're going to get the idea. Kenapa bila kita tepuk kuat, when we slam our fist, when we slam our palm at the on the table, it feel very very painful. But if you go it slowly, it's not. Same goes as this one. So if you go very fast, means you inflict an amount of force, an enormous amount of force to the surface of the table. At the same time, the surface of the table is going to return that amount of force to your palm. Sakit lah. Ni maksud yang ketiga. Okay, this is the meaning of the third one. Jadi, dia juga menceritakan some properties of Newton's second law. For example, kita ambil contoh ni kan. Kita ambil contoh sepak bola Okay. Let's play this one. Jadi pula.
In one nice know about this that you're not the contact on the ball.
Let's see. Dia kick macam ni tadi. Ya, betul. 6 second terus.
Yeah. The area is central and the contact have to follow through how you follow through.
Okay. Selajap perahu. Contoh lah kan. Bila nak sepak?
But not just.
Okay. Contoh macam tu. This column of peripherals produce force. And this force being transferred to the ball. Which cause the ball to travel. So, okay. Cause the ball to travel. So based on Newton's third law, what you give, you get back. Means if you try to get this ball travel fast,
the contact on the ball.
Okay, you need to kick the ball hard. Ni kita cerita keluar. Okay, tadi kita cerita tapak tangan ke dalam, means you feel the force back again. Now we talk about transfer of force. It follow the same rules. If you try to get more outcome, you need to give more to external force. Internally, when you kick the ball hard enough, you're going to feel sensation at the leg. Tak ada orang kan, bila dia sepak bola kuat, kaki dia tak rasa apa pun. Bola pergi sikit punya laju macam peluru, kaki tak sakit. No. Because you are going to exert the same amount of force from the ball. Okay, ni dia, maksudnya yang ketiga ni dia works two ways. One way, it transfer the force and make the ball goes. Secondly, it will absorb the same amount of force being transferred from the leg to the ball, which cause the leg to feel pain. Itu maksud Newton third law. For every action, there is an equal reaction, but opposite direction. Pergi 300, receive 300. Cuma yang pergi tadi positif, yang receive tadi negatif. That is just to show you the direction of the force being given and being absorbed. Okay. So when one body exert a force, the second body exert a reaction force that is equal in magnitude but opposite in the direction. That is what third Newton law talks about. Okay, baca dulu. Ini contoh dia lah. Okay, the last one is law of gravitation. Okay, law of gravitation ni, okay, to make things simple for law of gravitation, it is something like this. Newton said that every body is attracted to one another. Okay, macam kita kan, kita kata kita ditarik oleh bumi, so bumi ada gravity. Okay, the concept is that bumi, kita, buah, all is attracting. So bumi try to attract human to themselves. Kita attracting bumi. The fruits being attract to the earth, the fruits also try to attract earth. At the same time, we try to attract the fruits and the fruits try to attract us. Every body, bukan body, every body, our body begins with atom and molecule. All of that thing is attracting to one another. Tu maksud dia. Okay, maksud yang ini. All body are attracted to one another. But with a force proportional to the product of their masses. Means, if you are larger, if your mass is higher, your gravitational force is larger. So if we compare apple dengan bumi, bumi punya attraction is much higher compared to the apple. And so to do so, apple being attracted to the earth. Dah kita kata apple tu ada tarikan graviti jatuh ke bawah. Itu yang kita nampak. But it is due to the size. So the apple try to attract, but not powerful enough. Itu maksud statement yang kedua. Force proportional to the product of their mass. Lagi besar, lagi kuat attraction. Okay, kita ambil yang besar sikit. We take bumi, bulan, matahari. Okay, bumi, bulan, matahari. So if we hierarchy this thing, this one will have the most gravitational attraction. This is the second one, and this the least gravitational attraction. And that is the reason dia tak boleh ditarik oleh matahari. Tu yang point yang pertama. Okay, dan dia tak boleh tarik bumi, sebab bumi tarik dia. Point yang kedua, inversely proportional to the distance between them. Meaning that gravitational force higher, okay, gravitational force is higher, apa dia? Inversely proportional to the distance between them. If the distance is near, the gravitation force is low. If the distance is further, the gravitational force is higher. Okay, tu maksud dia. So that makes bumi ditarik oleh matahari. And this tarikan is much higher in term of value compare to tarikan dua ni. Pasal apa? Pasal tarikan ini dan tarikan bumi, the distance is near. So kita namakan D1, ni D2. So since D2 is further compared to D1, D2 have more gravitational force compared to D1, less gravitational force. Dia macam tu, okay. Lepas tu mass, bulan ditarik ke bumi because bumi have more mass compared to bulan and the distance is near. Okay, because dia near, dia ada tarikan, but the tarikan tidaklah sekuat tarikan matahari. Okay, matahari lagi besar, it has more mass, it has more gravitation. So dia menarik bumi. Itulah terjadinya paksi. Okay, scientifically speaking lah, based on gravitational theory. Tu dia. So dia bukanlah sengaja kita ditarik ke bumi, bulan ditarik ke bumi. No, it is due to two things. One, it is due to the mass. Two, it is due to the distance. Distance between mass. Okay, satu, dua. Ini konsep. This is just concept. Body attracted to one another with a force proportional to the product and inversely proportional to the distance between them. Inversely proportional. Okay, so dia terbalik in term of distance, but in term of mass, it is follow. More mass, more gravitation. Lagi jauh, lagi Contoh lagi jauh, so the mass the gravitation is going to be a bit higher. So benda tu akan sentiasa berada dalam satu paksi yang sama. Okay, ini konsep. Okay, tapi yang kamu kena faham ni 3 sampai law of reaction. Law of gravitation ni kurang. Okay, ada soalan lain? Ada soalan tak sebelum kita teruskan?
Saya ada soalan.
Mm-mm.
Untuk second law kan. Kan tadi saya cakap
Ni,
sekejap ni.
law of acceleration.
Kan dia force apply to a body cause acceleration of the body. Lepas tu kan sir,
Mm-mm.
kalau kita cerita pasal second law ni, dia memang dalam axis yang sama je ke macam mana?
Dalam apa?
Axis yang sama. Ke tak juga?
What do you mean by exist tu? Contoh.
Macam contoh yang saya bagi kan. Kan kalau force tu kita tolak ke depan kan. Lepas tu weight yang react dekat force tu akan gerak ke belakang. Kiranya
Macam ni lah kita
dia
ambil.
kan dalam axis yang sama je lah kan.
Kita ambil 2 condition kan. Okay, satu force macam ni. So weight will move this way. Another one force macam ni. Weight will be this way. Okay, axis yang mana lagi satu awak nak tengok? Daripada atas ke bawah? Is it macam ni? Force. Weight will be this way. If the force is something like this.
So total dia takkan campur macam X dengan Y punya axis tau.
Tak. Pasal dia punya konsep yang pertama, direction tu mesti follow direction force. So kita tak boleh ada force, lepas tu bergerak macam ni. Kamu nak macam ni kan?
Macam tu.
Ataupun macam ni, weight, okay, weight and then force. Tak boleh lah, pasal force kita tolak ke atas, weight dia memang akan bergerak ke atas ke bawah. Dia tak ada pada tepi. Okay, but the thing that you say, it is quite common if kita ada barang macam ni kan. Kita tolak macam ni, but it move this way. Kenapa dia move macam tu? Maksudnya force yang kita bagi tadi, dia daripada sini, dia daripada sini. There are 2 direction of force. So kita dapat the thing that known as resultant force. Ini dia akan follow teorem Pythagoras. Okay, kenapa jadi macam ni? Simple. When we talk about resultant force, ataupun when we talk about force, tadi kan kita ada force macam ni kan. We have horizontal force, we have vertical force, we have torque. Okay, we talk about these 2 things first. Swing, swing, swing. When we give force, we can give force from any direction, multiple direction, but it will always obey these rules. Okay, example, kita bagi satu force macam ni, kita bagi force horizontal. It will cause object gerak macam ni kan? Betul tak? Okay, if we give force vertical sahaja, it will cause this object, kita bagi force macam ni, it will cause the object to move this way. How about this? We give force diagonal. Macam mana kita nak bagi force diagonal? Maksudnya, okay, kalau kita nak, dia akan ada macam ni. We are going to have this one, means we need to give horizontal force, this amount, and vertical force, this amount. Maksudnya kita tolak dia tu diagonal. Ke depan pun ada, ke atas pun ada. So the question is, how about the weight? The weight will follow this one. Okay, kita ada objek. Kita tolak, kita bagi dia force macam ni. Means this force is inclusion of both horizontal component and vertical component. Jadi, objek ni akan bergerak ke sana. Betul kan? At the same time, if this object move this way, there will be resultant weight move that way. Maksudnya kalau kita keluarkan teorem Pythagoras yang kedua, force moving this way, ni, resultant ni. So we are going to have something like this. We are going to have an amount of vertical force and we are going to have an amount of horizontal force in vice direction. Tadi kita bagi macam ni. Sekarang dia patah balik in vice direction. It can happen like this. Jadi konsep yang sama lah. It will move at the same direction of the force being applied. So do the resistance. Jadi kalau kita bagi dia diagonal, resistance is going to be diagonal. Kalau kita bagi dia tegak, lurus, resistance will be dan tegak lurus daripada depan ke belakang. If we give resistance ke atas tegak, means that resistance will be ke bawah tegak. Boleh faham?
Faham sir.
Okay,
So dia punya apa macam calculation dia akan jadi lagi susah kan sir kan?
Tak juga. Kalau kata resultant macam ni kan, dia bagi resultant, means kamu kena cari ni lah. Ni lah value dia. R square equals to A square plus B square. Kena cari benda ni lah. Kalau yang tegak lurus tadi, we just go F. Satu je. Tapi kalau yang resultant ni, so F ni is this one. R square. So R equals to A square plus B square square root. Ni teori Pythagoras. Macam mana kita nak cari value hypotenuse. Okay, this one is only applicable if there are no mentioning of theta. Kalau dia ada mentioning theta, kita kena pakai sin, cos, tangent. Sin equals to opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Ni, opposite adjacent hypotenuse. Sin theta. This is theta, angle. Sampai sini nanti kita bincangkan benda ni. But it can happen like this. Okay, kenapa dia jadi diagonal? Aku kena faham konsep lah. Konsep, kalau kita nak objek bergerak ke depan, so FH, kita kena bagi dia value. Kalau kita nak objek tu, bila bergerak ke depan saja kan lurus, FH ada value. FY, 0. So, dia takkan naik ke atas. Okay, kalau kita nak objek tu bergerak ke atas je, means that Fy, kita bagi dia value. Fh, 0, Fy, Fh, ni Fv, vertical. Dia gerak ke atas. Kalau kita nak objek tu bergerak macam ni, Zohid, nampak dia ada curve. Meaning, Fh will have value, Fy pun will have value. Fv. Mabuk saya ni. Saya mabuk dengan huruf. Baguslah kamu dapat something yang bergerak ke atas, ke bawah. Okay, kalau value macam ni kan. Ni V, ni H. So, kita tahu FH is lesser than Fy. Kamu dapatlah curve yang tinggi ke atas. Kalau kita nak landai macam ni. This is Y. This is, H. So, here is FH is balik. Larger than Fy. Maksudnya dia takkan naik tinggi. This is what resultant. Okay, this is resultant. Now resultant. Tiga. This is resultant. Or sometimes you're going to hear the term diagonal. So it is angle. Angle. The movement is in angle, not in the straight line. Yet it still involve FH, FV. It still involve vertical and horizontal. So the resultant will always be the same as the force being given. Kalau force being given tadi vertical 10, horizontal 40, the resultant will be horizontal negative 40, vertical negative 10. Dapatlah resultant. So dia masih lagi sama, lagak-lagak still sama. Okay, boleh? Okay kah?
Okay sir.
Alright. Okay, and then ni simple, yang ni kita pergi laju. Senang, ni senang, bapak senang. Bukan main-main ni senang, memang senang. Okay. Type of motion. In human, we have 3 type of motion. Okay, contohlah orang. It move forward. Okay, based on what we have learned last week, in order to move forward, okay, lepas motor unit recruitment, kita akan ada joint motion. Lepas joint motion, baru kita akan ada skeletal motion. Barulah kita akan nampak movement. Okay, ni how human move, right? So movement here is, katalah kita nak dia ni walking kan. So we are going to see this fella walking forward. That is the movement. And the movement cause change of place from point A to point B. Okay, this is known as linear motion. Linear motion. Okay, what caused this motion? Skeletal. What causes skeletal motion? Joint. You are going to have rotation at the hip. You are going to have rotation at the knee, flexion, extension. Semua rotation lah tu. All of this rotation, rotational motion, where we have, okay, pergerakan macam ni, katalah saya keluarkan gambar. Okay, in order for you to move, you are going to have movement here. And this movement, this rotation, occurs with the presence of an axis of rotation. Ada paksi. When they are paksi, this is known as angular motion. And human motion cannot happen without angular motion. Kita dah cuba proofkan minggu lepas kan. Semua orang tak boleh bergerak tanpa pergerakan joint. Meaning, to have this action, it involves two type of motion, and this is known as general motion. Okay, contoh kedua, basikal. This bike move along the track. Setelah kita ada track macam ni track basikal selalu macam ni kan. Okay, it move along the track. Tegak sampai sini kita ada left banks, back lap sebelah kiri, dan tegak, and then kita ada another left bank. Okay, kita ada banking action. So tegak, belok, tegak, belok. Soalan saya, pergerakan ni, pergerakan linear ke angular? Daripada sini basikal, dia bergerak di sini. Daripada sini basikal, dia bergerak pergi sini. Is it linear or angular? Does this bike move linearly or angularly? Okay. Refer as translatory motion. It is also a motion along a line. Object will maintain angular orientation. Is it moving along the line? Kalau kita tengok gerakan basikal tu seketul, jangan tengok part-parts dia. Dia buka seketul ke depan. Although dia ada banking, bank here, bank there, it's still in a straight line. Okay, so when the bike move in a straight line motion, this is known as rectilinear. Still part of linear motion. And when the bike goes sideways, ambil left. Okay, maksudnya tadi dia jalan tegak, dia ambil seliku. Maksud dia jalan tegak, dia ambil seliku. Dia jalan tegak, dia ambil seliku. This part of selekuhness is known as curvilinear. Although it has some sort of rotation, yet it still move in one straight line. Unless dia buat macam ni. Zaz. This is angular. Because it has paksi. Selagi dia buat macam ni, bergerak, this is known as linear motion. We have the straight line, curvilinear. We have the banks, the laps as curvilinear. The straight line is rectilinear. Ni mungkin ada straight sikit. This is rectilinear. And then we have curve. This is curvilinear. This is another curve, curvilinear. This is straight, rectilinear. This is another curve, curvilinear. Tu curvilinear and rectilinear. Okay, the difference between those two. Rectilinear, if the path of one point of on object is a straight line. Curvilinear, curve. Okay, curve, not rotation. So this is curve, curvilinear. These two parts. This is straight, rectilinear. Both of this is still under linear motion. So kawan dia Ni contoh lah. Okay, rectilinear. Ni curvilinear. Nampak? Angular motion, bila dia berpusing. Weng, 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 weng. Why? This is the axis, the axis of rotation. So it causes rotational movement. Curvilinear bukan rotational movement. It's still one straight line, but in curve. Like rectilinear, it is in a straight line. Ni masih lagi satu line. Tapi line yang bengkok, curve. Okay, angular, it is in rotation. So when you see rotation, angular motion. Okay, tu. So combination, general motion is a combination of linear and angular. So most of human motion is general. Sama macam basikal ni. Basikal ni bergerak tegak. Tapi in order to get this tegak, you're going to have rotation at the wheels, rotation at the pedal. All of this is angular. So motion of the bike combination is general. Tapi kalau dia tanya basikal ni bergerak keliling track, pergerakan apa yang dia buat? That is linear motion. Because we see the bike as a whole. If you try to dissect the bike, wheels, sprocket, pedals, human, it become angular motion. And combine all those two, it become general motion. Ini 3 pergerakan asas. Linear, angular, general. Okay, macam bola ni. This ball travel forward. At the same time, it rotates. The pathway of traveling forward, that is linear. The rotation is angular. So the combination of these two, general motion. Itu 3 yang asas. And then we have oscillatory motion. Oscillatory ni back and forth recurring motion. So motion yang bergerak depan dan belakang. Okay, dia macam ni. Bila kita ada satu objek, katalah we have an object. Okay, kita angkat objek tu sampai satu tahap. We name it as X. And then we release the object. So the object will move to a point where we name this point as Y. And when we talk about oscillatory object, this same object will actually return to X and back to Y multiple times. Buat benda sama, depan dan belakang, depan dan belakang. And if we neglect friction, it won't stop. Okay, if we neglect friction, it won't stop. Why it happen like this is because of a property known as potential energy. Okay, potential energy ni ataupun kita namakan dia sebagai PE is height times weight. So katalah kita kira X height and weight of this object, it will have X, small x, it will have alpha value of energy. Okay, meaning that whenever the object reach a place, it will have energy equals to alpha. Okay, and when it goes down, this alpha energy will be recharged here because it is at the same height. So the same height have the same potential energy, and with the same alpha energy, it will return. It goes that way all the way. Kenapa dia boleh pergi tempat yang sama? Because the amount of energy is equal. When it reach the end point, the amount of energy stored inside the object is equal with the energy at the static. So it will goes another way and it will recharge that. It being recharged by height. Itu dia, itu potential energy, and this is what we know as oscillatory, pergerakan ke depan dan ke belakang. Ataupun nama lain dia simple harmonic motion. Okay, when the motion have a restoring force. Ni alpha energy tadi. Sampai sini alpha energy, contohlah sampai sini alpha energy dia 1. So bila dia balik ke sini, dia akan guna that one sampailah sini, dia akan ada alpha energy 1 balik. So it can goes back and forth until kiamat if we neglect friction. Tapi dekat dunia kita ada friction, we have air friction. Jadi alpha energy tu makin lama makin kurang. Tadi 1, bila dia patah balik sana dah tinggal 0.9, naik balik sana tinggal 0.8. We are going to notice that after 10 trial, dia dah berhenti kat tengah because there is no more energy to bring it back. Okay, ni salah satu contoh lah Ataupun contoh siapa yang rumah ada jam lama yang ada batu ladung kan, yang tak pakai bateri, so dia pakai movement of batu ladung. You are going to notice that the batu ladung can actually move for quite some time before it stop and you need to move it again. Tu contoh pendulum. Dia guna berat batu ladung and the height of the batu ladung to make it go back and forth. That is oscillatory motion. Every time it goes back, every time it goes forth, it will restore the same amount of energy. Okay, tu contoh. And then we have wave motion. Waving. Okay, when we talk wave motion, we can describe wave in two different forms: mechanical wave and electromagnetic wave. Mechanical wave that we can see. Electromagnetic is the wave that we cannot see. For example, cell phone. Cell phone pakai gelombang in order to get line. Radio pakai gelombang. All those wireless pakai gelombang. Tu electromagnetic. Matahari, we can see terang but we cannot see the sun rays, that is wave. X-ray, that is wave. Contoh mechanical wave, ombak, spring, the thing that we can observe. Okay, this is some sort of mechanical wave. So in mechanical wave, we can express, not in mechanical wave. In those two waves, mechanical and electromagnetic, the way we want to describe the power of the wave is by describing dia punya wavelength. We describe the wavelength. The longer wavelength has different function with a shorter wavelength. So, in order to describe wavelength, we have two methods. Satu, we describe in term of transverse wave. Wave ke depan, spring kan, kita tengok spring tu naik turun, macam ombak. That is transverse. Yang kedua, we describe in term of longitudinal wave, compression rate. Okay, so transverse ni, macam ni wave, kita lukis sikit. Okay, kalau kata transverse ni kan, wave yang macam ni, kita mungkin ada wave yang macam ni, kita mungkin ada wave yang macam ni. Ni wavelength dia, between one end towards another. This is, katalah kita panggil A, this is B. So wavelength B is longer than E. Itu yang pertama, in term of transverse. Yang kedua, in term of expansion. Kita akan ada, kita tengok daripada atas, we see from above. So we are going to see something like this. Lepas tu macam ni. Okay, so this is known as compress. Okay, lagi satu, known as expand. Okay, expansion. So wavelength can be described in these two things, in term of longitudinal or transverse. Okay, so transverse wavelength ni, dia mungkin longitudinal dia can be compressed, can be expand. Contoh macam ni kan, ni kita ambil wavelength pendek macam ni, lepas tu tengok pada atas pula, dia macam tu. Maksudnya the wavelength is short and it is compressed. Ataupun mungkin kita ambil yang ini, kita ambil B kan, jarak dia dah jauh-jauh, tapi dia punya compression rate tinggi. So the wavelength is long and it is compressed. So compressed wave is quite powerful. Compressed wave is quite powerful compared to the expand. Satu. Yang kedua, short wavelength is powerful compared to long. Okay. So kita letak sini lah, compress, power, then expand, expansion. Short wave, power, then long. Ini in term of power. In term of reachability, how far it can goes, long wave is better than short. Ini asas. Okay. So, kita tengok sini. Oh, sorry. Okay, kita tengok sini. This is electromagnetic wave. So, electromagnetic wave follow the same form as mechanical. It has wavelength in terms of transverse, and also it has compression and expansion. Same as longitudinal. Tapi, when we talk about electromagnetic, now we cannot see the wave. Okay. Example macam ni. Kita ambil radio. Okay, we take radio. Radio rumah tu. Okay, radio rumah tu dengan siaran handphone pula. Dengan line handphone. Dua thing. Those two is electromagnetic. Radio dengan handphone. Do you ever go to a place where there are no radio but handphone line is there? And do you ever go to a place where there are no line but radio will always be there? Pernah tak ada dekat tempat macam tu? Do you ever come to that particular situation? Line tak ada ni. Lautan ke apa? Radio ada. Boleh dengar radio. Radio standard, bukan radio kat handphone radio biasa. Handphone tak ada. Tak ada line. Do you ever come to that particular situation? Pernah tak? Pernah tak? Tak pernah?
Tak ada radio rasa.
Aduh. Kau ni dunia milenial.
Pernah.
Okay. Sebab dia kat sini. Kalau kita tengok sini kan. Kita tengok sini. Okay, we have AM radio. We have FM radio. Apa ni? Kita punya handphone tak masuk. Dia masuk ke kat sini juga. Okay. We are going to see that frequency. Kita tengok wavelength ni. Semakin ke sana, wavelength semakin pendek. Semakin ke sini, wavelength semakin panjang. Okay. And then, semakin ke sana, compression rate dia semakin tinggi. Semakin ke sini, compression rate dia semakin pendek. So, you're going to notice that radio, okay, radio ni, AM, FM, dia punya compression rate quite low. Tapi, dia punya wavelength panjang. Which result, it can reach towards a lot of place, tapi penetration dia kurang. Penetration dia kurang. Okay, jadi tempat kamu duduk dalam hutan tu, duduk pencawang dia mungkin jauh, dia masih boleh sampai. Not handphone. Handphone, wavelength dia pendek sikit. And that is the reason why it need a lot of repeater. Dia daripada KL, dia kena tembak pergi, let's say nak sampai Negeri Sembilan kan. Daripada KL, dia kena tembak UPM, UPM kena tembak Bangi kena tembak apa tu? Nilai kena tembak Pajam baru boleh tembak Seremban. It goes like that. But radio mungkin dekat satu je dekat KL, it serve sampai Negeri Sembilan. That is the difference in term of wavelength. Okay, however, bila wavelength panjang, selalunya penetration dia rendah. The expansion rate is less. Most of it is going to be expand wave. Dia bukan compress wave. Okay, jadi bila dia expand wave, dia langgar dinding, dia langgar apa, dia tak boleh tembus. That is the difference between this part and this part. Kalau kita tengok yang sebelah sini pula, kita ambil satu je, X-ray ni kan. X-ray, wavelength dia pendek. Okay, so shorter wavelength is much powerful. And then compression rate dia tinggi, so it can goes beyond surface. It can goes beyond surface, but the reachability is less. Dia kalau tembak kita punya tangan sampai lepas tangan tu je, dia tak boleh keluar daripada bilik tu because the wavelength is very short. Ni wave. Okay, this is wave. Longer wavelength can travel further. Shorter wavelength travel near. However, shorter wavelength penetrates because shorter wavelength have more compression compared to the longer wavelength. Okay, so tu wave lah. Contoh macam kita sekarang internet, okay, wifi. Duduk dekat college atau duduk dekat rumah, pakai router yang dulu yang standard router kan. Router duduk kat luar. Kadang-kadang dalam bilik pun line tinggal satu je. Kat luar kuat. Why? Because it use quite a limited wavelength and compression rate. It cannot penetrate dinding. If it can goes like that, meaning orang sebelah semua boleh dapat internet yang sama laju dengan kamu pakai kamu punya router. Itu maksud dia. Okay. So kalau macam sekarang is Wi-Fi, do you ever heard about Li-Fi? Pernah dengar? Like source. Li-Fi dia. Do you ever come across this one? Li-Fi internet. Ni Li-Fi Wi-Fi. Kau ni senyap je. Ada lagi dah ni. Halo, 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 halo. Are you in here?
Ada je.
Ada ke?
Ada tu.
Okay, Li-Fi ni. Wi-Fi is wireless internet. Li-Fi is actually light. Dia pakai cahaya. Meaning that it need to has a source of light. So the internet being connected by light.
जी हाँ दोस्तों वाई हो सकता है एक चीज़ है तो
Saya tengok dia punya konsep ni.
चेक करते हैं वाले और
Ni. It transmit data using light by LED bulbs. So Wi-Fi wavelength, that wavelength is quite long. Okay. Contoh kamu guna apa sekarang? Katalah macam saya U-Mobile. So that internet provider location is KL, Kuala Lumpur. It can reach up until Seremban. But Li-Fi, it is in confined space. Contoh dekat dalam bilik kamu, dalam bilik tu je dapat. Because as long as the light can penetrate, orang akan dapat Li-Fi. Tapi if it goes to the wall and it bounce back, mean that the Li-Fi connection is only in that particular room. Jadi dia adalah shorter wave. And shorter wave, dia adalah dia panjang but not as long as Wi-Fi. Itu yang pertama. Compression rate dia tak tinggi sangat because it cannot penetrate. Compared to Wi-Fi, it has the ability to penetrate. Cuma since it is only in one confined space, it able to transfer much better. Sekarang Wi-Fi paling laju berapa gigabyte per second? Siapa rumah pakai Wi-Fi gila babi melaju boleh jadi apa ni? Server ni. How fast is the latest one? Saya masih pakai yang lama. Dah diam balik. Hello. How fast is your Wi-Fi now? Berapa sekarang?
100 rasa.
100 gigabyte per second. 100 megabyte. Bukan dia dah sampai gigabyte ke?
100 Mbps.
Itu baru megabyte. 100 megabyte and then we have 300 megabyte. If I'm not mistaken, time network give 1 gigabyte per second. If I'm not mistaken lah. 1G. Bukan 1M lagi dah. Okay, 100 megabyte per second. Kalau kamu download satu movie, 1 gig punya movie, how long does it take?
Seminit.
Seminit. Kalau kat rumah saya, satu movie it cost me maybe 6 to 7 hours. Saya punya lagi rendah kat rumah tu. Download dalam hutan. Li-Fi able you to download 25 to 35 movie simultaneously in less than 10 second. Okay, 30 movie download on the spot, pakai 30 PC, less than 10 second. Sekali buat. Tu Li-Fi. And you can now, you're going to have, you can actually imagine the speed of that. Tapi dia confined di satu tempat je. Means it need to go to your house via device, via cable or whatsoever, and then it can only encompass one room. So kalau kamu nak banyak bilik guna Li-Fi, you need to have banyak dongle Li-Fi. Dia macam tu. Wi-Fi tak perlu. Kalau you pakai yang latest router, one router can actually support 2 to 3 home. Dah cukup kuat because of the penetration. Li-Fi tak boleh penetrate. Dia cahaya. Kita buka lampu dalam rumah, luar pun tak dapat lampu tu. Tu Li-Fi. That is the not so latest lah. Okay, tapi antara yang terbaru. Okay. Alright. Fluid motion tak payah. Okay, and then we have fluid motion. Fluid motion is actually any movement that happen in fluid condition. So we as human is actually works in fluid. Okay, fluid ni termasuk dua lah, gas and liquid. Dalam air pun fluid, dalam angin pun fluid. The only terms that you need to remember for fluid motion is actually Magnus effect. Nah, ni Magnus effect. Okay, so Magnus effect occurs when there are differences in terms of the rotational of the object with the movement of the of the air, the movement of the liquid. So we are going to have either a lift up ataupun a knuckleball. Bola tu boleh jadi bola ke atas, bola tu boleh jadi bola ke bawah. It depends on the rotation. If the ball rotate here, so it will cause the ball to drop. If it change the direction of the ball, if the ball move here, it will cause the ball to rise up. If we change the direction of the ball rotation, it will cause the ball to drop down. Ni nama dia Magnus effect. So in real life is some sort of like apa tu yang buat banana kick tu kan, budak Malaysia yang buat banana kick tu, yang dapat anugerah Puskas tu. So that is some example of Magnus force. How Magnus force change the direction of an object? It due to pressure. Ni nanti kita akan sambung dekat pressure lah. Okay, bila kita sampai sini. Alright. So any question? Part 2 ni panjang ni. Saya tunjuk sikit. Ada soalan tak sampai sini dulu? Sampai type of motion. General, angular, linear, oscillatory, and form, and wave. Wave, we have two, mechanical and electromagnetic. So you can describe that in terms of transverse and horizontal. Expansion, compression, and wavelength. Sampai situ. Do you have any question? Ada soalan? Enggak ada.
Tak ada, sir.
Enggak ada. Okay. Kalau enggak ada, we go to the second one. Impulse momentum. Ni saya tak sentuh semua, panjang ni. Besok pun tak habis. So I'm going to talk about the concept behind this. Okay. To talk about impulse momentum, kita cerita paling mudah nak faham, kita cerita pakai bowling. Okay. Kita pakai bowling. Let's see macam mana. Okay, bola lah. Sini. Saya punya orang sama je rupa dia. Macam ni lah. Ya, bola bowling. Okay, so they are going to roll the ball and they are going to have pin. Okay, so when we roll the ball, goes like this, the ROM. Okay, what actually happen is you are going to supply force from the muscles to the ball. It will cause the ball to rotate. At the same time, move forward. Ini yang terjadi, okay? This is apa yang terjadi. Alright. When we talk about force, object, and movement, there are three different terms that play in mind. The first one is force itself. Force equals to mass and acceleration. So force here, mass is actually the mass of the hand. The acceleration is the acceleration of the shoulder girdle. Baru kita boleh dapat tahu berapa banyak force kat sini. Itu yang pertama, konsep yang pertama. Okay, you need to give force in order to make this object move. Okay, when we talk about force, an object in motion, it will involve another two different and important concept in kinetics. The first one is known as impulse. I equals to Ft. Okay, this one is impulse. This is force. This is time. And then the second concept is M capital equals to mv, small caps. M capital is momentum. M small is mass of the object, and v is velocity. Okay, so impulse can also be described as the amount of force in a given time, while momentum can be described as the amount of movement. Okay. And at every single point of time, if the object has an impulse, it will always has momentum. So we can come up with impulse will always be similar as momentum. It will always be similar. Okay, ni konsep dia. And this concept come from the another concept known as impulse momentum theorem. Ini adalah benda ni. Impulse momentum theorem is this one. This is impulse momentum theorem. Okay, so impulse momentum theorem, it came from the source of everything, force. Okay, sekarang kita tengok mana dia datang. F will always equals to M E. Okay, I equals to F T and M equals to M V. Okay, we start from here. So we go F equals to M. A ni, we are going to write it up in a full form. V2 minus V1 over T2 minus T1. Okay, itu yang pertama. Yang kedua, we are going to shift the right hand side equation to left hand side. And we are going to multiply the out of the box with the inbox. So you're going to get F T2 minus T1 equals to, ni kita darab masuk ataupun kita biar je bentuk asal dia, V2 minus V1. You're going to get something like this. Okay. And when you see an equation which involve the same thing with two time frame, okay, so T2 here represent time final, T1 here represent time initial. Same goes as V2 velocity final and V1 velocity initial. Okay, if you see these two things, we can substitute the numbers or we can make it simpler by change the numbers and the alphabets into these symbols which represent the change of. Okay, jadi kita tukarkan, kita mudahkan dia lagi. So you're going to get F, the change of T equals to M, the change of V. So F, change of T is impulse. Ingatan ni. And M, change of V is momentum. This is how you got I will always be equals to M from the force itself. And this is what we call as impulse momentum theorem. So by knowing this, you know that I equals to M. Itu yang pertama. Yang kedua, Ft equals to Mv. Ni benda atas. Yang ketiga, since I equals to M, I also equals to Mv and M equals to Ft. Kamu ada 4 benda sekarang kamu boleh gunakan. Number 1, number 2, number 3, number 4. These 4 things represent the same properties, which is the amount of force and the value of movement. Okay. Jadi maksud dia, when you give force to this bowling ball, at that instant, this bowling ball is going to have impulse. Okay, it will have impulse, and this impulse cause the bowling ball to move. And when this bowling ball is in motion, it has momentum. Okay, sekarang bola ni ada impulse, bola ni ada momentum. Momentum menyebabkan bola ini bergerak up until here, where the ball is going to have a contact with pin. And when the ball contact with the pin, remember tadi dia bawa momentum, meaning dia ada impulse. When contact happen, the value of this impulse will be transferred from the ball to the pin, cause the pin to scattered around. Scattered around is motion, that is momentum. Ini konsep dia. So whatever thing you do, it will involve impulse and momentum. Such as when you kick a ball, your leg will have an impulse. It will be your leg will have force. It will be transferred to the ball. That is an impulse. And when the ball get an impulse, it will cause the ball to travel. That is momentum. And with that momentum, katalah keeper tahan, keeper will feel force because that momentum will transfer impulse to keeper hand, which cause the keeper to move the hand. That is the new momentum. So in any given point of time, impulse and momentum is equals. And the second concept is momentum will always being conserved. Sentiasa akan disimpan dan sama. For example, we have an object tadi, bola bowling. It has momentum. And then we have bola pin bowling. It also has momentum. And when it collide, it will become a new complex where it will has new momentum. And this new momentum, momentum 3 is actually combination of those two, because momentum will always be conserved. Dia sentiasa akan disimpan. The change is only towards either one of these. Mungkin lepas dia berlanggar dia jadi lagi berat tapi perlahan. Contoh paling mudah macam ni. Kita ada dua kereta kan, dua kereta bergerak. Satu bergerak pada kelajuan 80, satu lagi bergerak pada kelajuan 110. 100. Berlanggar. So lepas berlanggar, kereta ni dia akan jadi satu kompleks baru melekat. Dia mungkin akan bergerak. Dia mungkin akan bergerak, tapi berat dia dan pergerakan dia akan menyebabkan this momentum is equal. Tak faham? Contoh. Mamat A, mass is 80 kg. Move at 20 meter per second. Laju ni. And Mamat B, mass is 50 kg. Move at 30 meter per second. Berlanggar. Berlipat. To solve this one, you are going to use principle of momentum conservation equation. It will be like this. M1, V1. This will serve as 1. This will serve as 2. Plus M2, V2 equals to M1 plus M2, V. Kita selesaikan satu-satu. M1 80 kali dengan 20. Tambah M2 50. Now is the trick part. M2 move in vice direction. So this one is going to be negative. Tu kena ingat tu. 30 sama dengan 80 tambah 50 V. Ni dapat apa ni? 82 16 1600. Tambah 5 kali 3 15 1,500 tambah dengan tolak jadi tolak. Sama dengan 80 50, we have 130 V. So 1615 we have 100 sama dengan 130 V. So V will be 100 bagi 130. How much? .77 dapat 0.77 meter per second. Meaning that after collision ni, both of these new complex will actually move in the direction of number 1 at a speed of 0.77 meter per second, because this new complex will conserve the same value as before. Cuma apa yang berubah? Rupa dia dah berubah. Laju dia dah berubah. Tadi satu bergerak 20, satu bergerak 30. But after the collision, both of the object, both of the party move at only one direction at this speed with the new mass. Ni maksud dia principle of conservation. Sebelum dan selepas, momentum will always remain. The change may be towards the speed, may be towards the mass of the object, because they are new complex after the collision. This is what principle of momentum conservation talks about, and it is actually part of impulse momentum theorem. Okay, sampai situ dulu. Boleh faham? Ada soalan tak? Mana siapa ni tuan-tuan tadi? Can you understand that? Saya bagi contoh satu lagi. Delete. Okay, example. Bowling tadi kita ambil bowling tadi. We have time, a bit of time. Okay. Ada orang dia dalam kelas ni. Saya cakap seorang-seorang, diam je ke semua ni. Can you understand me?
Ada Zah.
Okay.
Ada.
Okay, katalah kita bagi dia impulse. I equals to Ft. So the amount of force being given here is, let's say, 100 Newton. And time untuk ROM ni dilakukan is 1.2 second. Okay, so we have 1.2. Berapa dapat ni? 1, 2. 120. Betul tak? Is it true? Is it true? Senyap ni korang ni.
Betul.
Ha?
Betul.
Macam betul. Okay. Ini impulse. The ball had an impulse of 120 Newton per second. Okay, when the ball move, it will has momentum. Okay, katalah bola bowling berapa berat How much is the weight of bowling ball? Anybody know? Siapa-siapa main bowling? Saya tak main bowling.
7 kilo se.
Berapa kilo?
Ya, ada yang 25, ada 5.
Okay, kita ambil yang paling ringan kali.
7.
7 kilo.
5 kan.
7.5. Okay, 7.5 lah. Katalah the weight of the ball is 7 the mass of the ball is 7.5 kg. Okay. So sekarang kita dah ada mass. Kita nak tahu berapa laju bola ni dengan impulse of 120 Newton with 7 kg mass of the ball, how fast the ball travel. So kita kira yang kedua. M equals to mv. Momentum dia berapa? Sama dengan value dengan value impulse. So it will be 120 equals to mass 7.5 kg, and then velocity nggak tahu. So velocity-nya ialah 120 divide by 7.5 kg. Okay. 120 divide 7.5. 16. Dia dapat 16. Okay, 16 apa dekat sini? It will be 16 meter per second. This is the speed of the ball. Okay, so we know that the ball momentum here is the ball velocity here is 16 meter per second. Okay, now this ball move and will hit the pin. Okay, dia akan langgar pin itu, meaning that, okay, let's say pin ni, berat pin ni, berat pin bowling berapa satu? Weight of bowling pin. Of bowling pin. 3 pound, 6 ounce. 3 pound converter. Okay, weight. Pound to kilogram. 3 pound, 1.36, 1.4 kilo. Okay, katalah satu ni berat dia 1.4 kg. Okay, 1.4 kg. So, kita ada 10, 14 kg. Roughly lah. Okay, 14 kg. Right. So, we have mass for the new complex is 14 kg. My question is, will this ball mix all the pin scattered around? Bila dia berlanggar tu, dia akan menyebabkan bola ni, pin ni bersepah ke tak? So, let's calculate dia punya velocity baru. Okay, always remember this ball travel at 16 meter per second. And then, the impulse here is 120 Newton per second. So, my question is, what is the new V for the complex? So, kita boleh kira pakai benda yang sama. M equals to MV 120 equals to 14 V. So, V equals to 120 over 14. 8.5. So, you are going to get 8.5 meter per second. Means all the ball is going to scatter after being contact with the bowling ball. Ni cara kita gunalah, kita transfer. Okay, so means that by having this amount of force, it can actually knock down all the pin based on weight, not based on direction. Kalau dia tak masuk poket, jadi bersepah juga. Ni cara kita kira and kita guna the impulse and momentum. Okay, so satu lagi contoh, saya takkan kira yang ini, but I'm going to give you an idea about it. Is this one. Let's say we have soccer player. Okay, soccer player. Alamak, kaki alien. Okay, this soccer player kick a ball. And then a keeper catch the ball. Okay, so when the soccer player kick a ball, it will inflict impulse. And it cause the ball to have momentum. When it goes to the keeper, this contact will also will also give an impulse to the keeper hand. Jadi by manipulating several aspects, we can make this action much safer. Okay, tu contoh dia. Okay, 10 minit. Okay, contoh kita kira bola ni, kita assume, let's assume thing. Momentum equals to mass bola 500 gram, velocity bola let's say 10, 3 saat, 45 meter saat. Okay, so momentum, berapa banyak momentum dia ada kat sini? This will be 0.5 time with 45. Berapa dapat? Salah. 45 kali
22.5.
22, half of it. Okay, so meaning that this ball has a momentum of 22.5 Newton per second. Okay, katalah bila dia ketangkap ni, so kita akan kira impulse kat sini. Impulse equals to Ft. The thing that we have, we need to focus on is the F. Okay, katalah this keeper catch the ball macam cerita Inazuma 11. Tegak tangan tu, dia tangkap bola, berhenti. So, first technique, the time taken to stop the ball is 0.5 second. Now, let's calculate berapa banyak impulse dia ada. Okay, I1 equals to F 0.5. I dia ialah 22.5. So, F dia ialah 22.5 divide with 0.5. Berapa dapat ni? Kecil ni value ni. 45. Okay, let's say human hand can only absorb 40 Newton. So what happened to the hand? if now it being subjected to 45 Newton. Apa jadi kat tangan ni? Dia boleh tahan 40 je. Sekarang dia dapat 45. What happened to the hand?
Cabut je.
Okay, cabut. Injured lah, injured. Okay. So we change the technique. We give the keeper glove, which will absorb, meaning that the time taken will be prolonged. So the second technique, by using glove, the time taken now become 1 second. Untuk bola tu contact and stop, it takes 1 second. So now let's calculate I2. I2 equals to Ft. So I still is the similar 22.5. F and the T now is 1. Okay, jadi kita ada F equals to 22.5 divide by 1. 22.5 Newton. Now the keeper safe or not? Does the keeper hand safe?
Safe. Sebab dia kurang daripada force.
Ya, okay. Katalah kita increase the technique a bit. Now with the glove and we retract the hand. Tangkap bola, kita tarik tangan ke belakang. So it further enhance the time to 1.2 second. Kita kira I3 equals to Ft. 22.5 equals to F 1.2. So F equals to 22.5 divide 1.2. How much we have it?
$18.75.
18.75 Newton. This is what impulse momentum being used for. Some of it. Technical contoh Jadi kita tengok sini daripada 0.5 pergi 1.2. The increment is just 0.7 second. It turns the net force from 45 to 18.75. Banyak tak? Tolak 45. Berapa penurunan dia? We have 26.25 Newton less than the first technique. This is how we use biomechanics in order to prove thing or in order for engineering. Ni dalam satu konsep je, dalam konsep impulse momentum. So we know that by change the technique, it save the players. By change the equipment, it save the players. By change both, it further increase the efficiencies of the process itself. And this is how we use some part of Newton law dekat sini, which is impulse momentum theorem. Okay, we are going to stop here. Any question? Ada soalan? Enggak ada. Ada soalan lagi? Kita habiskan kelas kita di sini because already 11:53. So we are going to continue with the summation of force in our tutorial class. Okay, so nota tadi kalau kamu tengok part 1 ni, belakang-belakang ni dia bagi contoh-contoh lain, and then dia bagi the same thing that we have discussed about impulse, about momentum, and about the principle of impulse momentum conservation and how we want to manipulate impulse and momentum. So I'm not going to repeat the same thing again lah. So please read through the example that been given. And next class we are going to continue with principle of summation of force. The notes is still at the same notes towards the end. Okay, ada apa-apa soalan?